Okay, good morning students. This is the 11th part of Parabola. Today I am going to explain the concept of chord of contact and pole and polar. So this is important and difficult concept. So already we discussed in circles about chord of contact and pole and polar and their equations and problems based on these concepts. Okay, actually the definitions of chord of contact and pole and polar all are same for all conic sections like circles, parabola, ellipse and hyperbola. So that's why first of all again I want to define the chord of contact for any conic and pole and polar for any conic. First of all I want to define chord of contact for any conic. Okay. So for example, this is a conic equation, say either parabola or circle, whatever it may, or ellipse, whatever it may be. Okay, from external point you can draw two tangents to conic. So external point you can draw two tangents. So external points you can draw two tangents. Okay. The point of tangents are joined, then we will get a line. The line is called chord of contact. The point of tangents are joined, that line here for circle is called secant. This line is called chord of contact of this point with respect to this conic. This line is called the chord of contact of this point with respect to this conic. So for example, these are the point of tangents is for ellipse. This line is called the chord of contact of this point with respect to this conic. This is the definition of chord of contact of a conic. Next concept is how to find equation of chord of contacts. So important thing is equation of any conic, the equation of chord of contact is S1 equal to 0 only. Important thing. Here S1 means xx1 plus yy1 plus z times of x plus x1 plus f times of y plus y1 plus c equal to 0. Here in this situation S1 means yy1 minus 2a times of plus x1 equal to 0. So this will become the equation of chord of contact for this parabola where p is given as x1 y1. For example, this is given as x1 y1, circular equation is given as c equal to 0, then this become the equation of this chord of contact. Similarly, equation of ellipse is given as x square by a square plus y square by b square equal to 1, for example standard one. So xx1 by a square plus yy1 by b square, okay nana. So minus 1 equal to 0 is taken as the equation of chord of contacts for this ellipse. That's why the definition of chord of contact is applicable for all conics. Here the definition again, if two tangents are drawn to a conic from external point, the secant line joining the point of contact is called chord of contact. Present chapter is parabola, no? So I want to explain the concept of chord of contact for the parabola. So and how to find the equation of chord of contact of the parabola. So this is a parabola standard form, that is y square equal to 4x nana. So this is external point P whose coordinates are taken as x1 comma y1. Through the point P I can draw two tangents. This is one tangent, this is another tangent. Okay, observe all of you. So this is point of tangency na, say A, this point of tangency B. Okay, if A and B are joined and extended, you get a straight line. A and B are joined and extended, you get a straight line. This straight line is called the chord of contact. I will write here chord of contact. Of P with respect to y square equal to 4x. But how to find equation of this chord of contact? That is important thing. This is, I can say, theorem 1 for this subtopic. the equation of chord of contact of P x1 y1 with respect to y square equal to 4x is s1 equal to 0. Here this parabola is given as y square equal to 4x nana. External point is x1 y1. PA and PB are tangents. Okay. Yeah, A and B are point of tangencies. A and B are joined. You got a line. Equation of this line is given as s1 equal to 0. That should prove now. Listen. Let PA comma PB are tangents drawn from P x1 y1 to y square equal to 4x. Okay. Let A equal to alpha comma beta comma B equal to gamma comma delta be the point of tangencies. Okay, Ranan. So actually we want to find the equation of a line which is passes through A and B. For that, what is here P and PA is the tangent. For example, this is the any conic. A point is given here P. Through P a tangent is drawn. You know how to find equation of this tangent. That is nothing but s1 equal to 0 only. Same. Here P is outside, no? Here P is on. P is on means through that point you can draw tangent. What is the equation of the tangent? That is nothing but s1 equal to 0. If P is outside, chord of contact is become s1 equal to 0. Not yet proved. But this one already proved, no? P is a point on any conic. Clearly I am showing any conic. I am not saying the parabola. P is any point on conic. Through that point you can draw a tangent. Equation of the tangent is s1 equal to 0. Already proved in circles. Already proved in parabola. Okay. So I want to use that concept here. Observe here, students. Yeah. Equation of tangent at A alpha comma beta is actually, what is the equation? I will write y1 minus 2a times of x plus x1 equal to 0. This is the equation of the tangent. So instead of x1, this line is passing through alpha comma beta. No, instead of x1 you need to write alpha. Instead of y1 you write beta. That is y beta minus 2a times of x plus alpha equal to 0. This is equation number 1. This is the equation of tangent drawn through A. Yeah. So I don't want to take it as a 1 nana. So do one thing. Okay. Right. But this line is passing through x1 y1. I can say p x1 y1. So now instead of y I can write y1, instead of x I can write x1. So I will write in next page. Yeah, what is that? y1 beta minus 2a times of x1 plus alpha equal to 0, and now I can say this is 1. Similarly, I want to find equation of the tangent at beta at B nana. I will write equation of tangent at B, that is gamma comma delta, is directly I want to write y delta minus 2a times of x plus gamma equal to 0. Again this line also passing through p x1 y1 only, no? This line also passing through px1 y1. So what happened in this equation? Instead of x you want to write x1, instead of y you want to write y1. y1 delta minus 2a times of x1 plus gamma equal to 0, equation number 2. So here we will get important and interesting conclusion. Observe all of you, Nana. I will write from 1 and 2. We can conclude the line y1 minus 2a times of x plus x1 will passes through alpha comma beta and gamma comma delta. So how you got this conclusion? That is important. Observe here, Nana. Yeah, this is straight line. Instead of x you write alpha, instead of y you write beta. Then what happened? Beta y1 minus 2a times of alpha plus x1 equal 0 only, no? 0 equal to 0 only. From equation number 1. Means this line is passing through alpha comma beta. Do one thing. Instead of x you write gamma and instead of y you write beta. What will delta? Delta y1 minus 2 times of x plus gamma plus x1 equal to 0. Means 0 equal to 0 from equation 2. What is the meaning of that? This line is passing through two distinct points. Through two distinct points, you can draw only one straight line. That's why this is the required line which is passes through A and B. So this is said to be the equation of chord of contact. So equation of chord of contact of px1 y1, important px1 y1 with respect to what is that? Y square equal to 4x. Don't confuse, Nana. With respect to y square 4x is not only for y square equal to 4x, any conic s1 equal to 0. Should remember, this is important. Okay, one example problem. Example 1. Find the chord of contact for some point, say p1 comma 2 with respect to y square equal to 8x. Okay, solution. Students, observe here. Yeah, given conic or given parabola, what is s? That is that y square minus 8x equal to 0. Chord of contact. What is chord of contact, Nana? S1 equal to 0. I already explained how to write S1 from S. So instead of x square you want to write xx1. Instead of y square you want to write yy1. Instead of x you want to write x plus x1 by 2. Instead of y you want to write y plus y1 by 2. Okay, constant should be no change in constant. That's why you can write here S1 means, in this example, y1 minus 8 times of x plus x1 by 2 equal to 0, or y1 minus 4 times of x plus x1 equal to 0. This is the equation of chord of contact with respect to the point x1 y1. But with respect to the point 1 comma 2 you want, no? 1 comma 2 means instead of x1 you want to write x1, instead of y1 you want to write 2. So I can say 2y minus 4 times of x plus 1. Okay, you can cancel with the 2, Nana. Y minus 2 times of x plus 1 equal to 0, or 2x minus y plus 1 equal to 0 is the equation of chord of contact. Okay, Next example, example 2. Find the equation of chord of contact of say point 1 comma 3 with respect to y square minus 4y minus 3x plus 2 equal to 0. Okay. Interesting thing is the given parabola is not in standard form. No need to convert into standard form. Okay, I will write parabola S equal to or S. Okay. What is that, Nana? Y square minus 4y minus 3x plus 2 equal to 0. No, directly I wanted S1 directly, just now explain, no? y1 minus 4 times of y plus y1 by 2, 3 times of x plus x1 by 2 plus 2 equal to 0. No changes in constant. Okay. Or another words I can say 2y1 minus 4 times of y plus y1, okay, minus 3 times of x plus x1 plus 4 equal to 0. This is the equation of chord of contact with respect to the point x1 y1. But you want with respect to the point 1 comma 3, no? That's why instead of x1 should write 1, instead of y1 should write 3. So what happened? 6y minus 4 into y as it is, y1 is 3, minus 3 into x as it is, x1 plus 4 equal to 0. We need to simplify this. 6y minus 4y minus 12 minus 3x minus 3 plus 4 equal to 0. Okay, now I want to simplify, minus 3x plus 2y. Yeah, what happened here? Minus 15 minus 11 equal to 0. Or another way I can say that 3x minus 2y plus 11 equal to 0 is the required equation of chord of contact of P1 comma 3 with respect to given conic. Okay, students, next example 3 I can say, this is example 3. Find the equation of chord of contact of 2 comma 3 with respect to y square equal to 4x. One problem. And also find point where chord of contact intersect the parabola. And equation of tangency at the point of intersection. 3 problems are there. One by one I will explain here. So direct, direct. So first of all, S I will write, that is y square minus 4x equal to 0. From that I want S1, S1 I want, what is that? y1 minus 2 times of x plus x1, directly I wrote, that is not big problem. So S1 at what point do you want? 2 comma 3, that is chord of contact, no? I will write chord of contact of P2 comma 3 with respect to y square equal to 4x. E is directly I want right answer. E is this one only. Instead of y unit at 3, 3y minus 2 times of x plus 2. Okay. Or another words I can say 2x minus 3y plus 4 equal to 0, Nana. Observe. 2x, okay, plus 4, okay. This is the equation of the chord of contact. Yeah, one thing completed. Next, find the point where chord of contact intersect the parabola. For example, this is the parabola, this is the chord of contact. Now you want to find the points A and B. After finding points A and B, through A you can write tangent, through B you can write tangent. Next we want to find equation of those two tangents. Okay. First of all, I want to find A and B. Now I will solve this linear equation with the y square equal to 4x. That's why I want to make y subject here. I want to make y as subject here. So y equal to 2x plus 4 by 3. So y square equal to 4x. Instead of y, what can I write? Wait. 2x plus 4, 2x plus 4, 2x plus 4 by 3. Students, you can take 2 common. 4 times of x plus 2 whole square by 9 is equal to 4x. This 4 get cancelled. So x square plus 4 plus 4x equal to 9x. Or another words I can say x square minus 5x plus 4 equal to 0, or x minus 1 into x minus 4 equal to 0, means x is equal to 1 or 4. Okay, means these are the x coordinates of point A and B respectively. Now I want to find the value of y. So by using this equation or any one, so I will write here, if x is equal to 1, then y equal to, what is the formula actually? 2x plus 4 by 3 actually, that one. That's why 1 means 62. Okay, means what is that? What is the conclusion here? Directly we got the coordinates of A, that A is nothing but 1 comma 2. Okay, if x equal to 4, then y equal 4 to the 8, 8 plus 4, 12, 12 by 3, that is equal 4. So directly I can conclude that the point B nothing but 4 comma 4. So what happened finally? 8 1 comma 2, B 4 comma 4. So this is the parabola y square equal to 4x. Okay, Nana, this is one tangent, this is another tangent. Okay, we got A equal to 1 comma 2 and B equal to 4 comma 4. Now next target is you want to find equation of this tangent as well as equation of this tangent. Okay, I will write equation of tangent for y square equal to 4x at 1 comma 2. Direct formula, no? What is the formula? S1 equal 0 only. What is that S1 means, Nana, here? y1 minus 2 times of 2a times of x plus x1 equal 0. For the a means 1 only, here directly I can write y1 minus 2 times of x plus x1 equal to 0. A equal 1 only now. For what point? 2, 2y equal 2 times of x plus 1 equal to 0, or x minus y plus 1 equal to 0. This is the one of the equation of required tangent. So another one, second one you want to find. So I will write equation of tangent at the point B, Nana, that is 4 comma 4, is same S1 equal to 0, that is y1 means 4 minus 2 times of x plus 4. You can cancel with the 2, Nana, 2y minus of x plus 4 equal to 0. So another words I can say that x minus 2y plus 4 equal to 0 is equation of another required tangent. Okay, students, another important concept, pole and polar. Pole and polar. So first of all, I will explain the definition of pole and polar for any conic. Observe here. So any conic, this is parabola, this is circle, this is ellipse. For any conic, hyperbola also correct, that is not big problem. Okay. From any point P in the same plane, no need to mention that P is exterior, no? Anywhere, somewhere, for example, P is taken as here, P is taken as here, P is taken as here. Through P you can draw infinitely many lines, infinitely many lines. Okay, so that line intersect the conic at two different points. For example, intersect at two different points, at two different points. Here at two different points. Okay, students, listen. At these two different points you can draw two tangents. They are intersecting here. At these two different points you can draw two more tangents. They are intersecting here. The point of intersection of all such tangents will form a straight line. That straight line is called the polar of this point P, and P is called pole of that polar. This is applicable for all conics. Here, this is about a parabola for circle. Through these 2 points you want to draw tangents. Their meeting point is here. Meeting point is here. Like that you can infinitely many, if you take all infinitely many pair of tangents, all will meet at these points only. So I think here onwards, here onwards, here onwards, we will get these points. So we can say that those points will form a straight line. The straight line is called polar of the P, and P is called pole. Here also, here also, here also, here 1 point, here 1 point, we get one straight line. Okay, so this straight line is called the polar of the point P with respect to this circle, this ellipse actually. For any conic this happens, any conic, the polar of a point with respect to a conic is a straight line containing the point of intersection of the tangents drawn at extremities of the chord passing through the point. Understood? Okay, now parabola is given. The point is taken P outside, maybe inside or maybe on, that is not big problem. So just lines are drawn so that they intersect the conic at two different points. Then you can say that this is chord, no? This is another chord. Through extremities of chord, tangents are drawn. Through extremities of chords are drawn. Observe here. The polar of point with respect to a conic is a straight line containing the point of intersection of the tangents, drawn at the extremities of the chords. Extremities of chord passing through that point. Through this point you can draw infinitely many chords. Using the extremities of those chords you can draw infinitely many pair of tangents. The point of intersection of all those tangents is taken as the polar of the given point P, and P is called pole of that polar. This is the concept of pole and polar for any conic. In circles, I clearly explain about pole and polar, conjugate point, conjugate lines, everything explained. Same concept is applicable for any conic. Especially for circle, P is external point. We can draw several lines. We get infinitely many chords. These two are such chords. Through extremities of chords, we need to draw tangents. This is one point of interest. Like that, we get infinitely many points. So all those points will form a straight line. The straight line is called polar, and this is called pole. Important thing, in circle, P is exterior point, then this is the polar. So in circle, P is on the circle, then where is the polar and where is the pole? Pole means P only, where is polar should identify. So through P draw tangent, the chords, infinitely many chords can construct. Okay, so through P draw a tangent. So through this point also draw tangent, they will meet at this point. Through this point you need to draw tangent. Already this is tangent to extremities, they will meet at this point. Already for this chord, already this is one tangent, one extremity. Through this extremity you need to draw tangent, they will meet at this point. this all will form a straight line. What happened in a circle? If P is on the circle, through that P you can draw a tangent. That only become the polar. See here, polar and tangent are same here. Here only polar. Through P you can draw tangents. No, two tangents you can draw. Those two tangents are not polar. The equations are same. The positions are not same. Here what happened? Equations and positions are same when the point is on the circle. Okay. P is inside the circle with one condition: P should not be the center of the circle. So P inside the circle now. Here also, if P is inside circle, this is one chord, this is another chord. Okay, no. So through two extremities of this chord, I can draw two tangents. Through extremities of this chord, I can draw another two tangents. They will meet at some point. All these points will form a polar. What happened? If P is inside the circle, polar is outside. So important thing is P should not be taken as center of the circle. I clearly explained. Why? Because, for example, P is taken as center of the circle. So diameter becomes chords now. Diameter becomes chords now. So through extremist diameters, if you draw tangents, they always parallel. They won't meet means they won't form such points. Means polar won't form. That's why if P is taken as center of the circle, there is no concept of pole and polar. Okay, students. No, just I explained. No, I want our present concept is parabola. No, yeah, this is the parabola. No. So P is external point. Through this point, you can draw infinitely many lines. Shit. So this is one of the line. So say this another line. Okay. So this is chord. Say AB is one chord. CD is another chord. So what should do now? Now at A, we need to draw tangent. Sorry. Through B also you need to draw tangent. Through C you need to draw tangent. Through D also you need to draw tangent. Okay. So assume that this is the point of tangency of all. Now we need to draw a line passing through these two. Yellow color line is said to be the polar of P. Now I will write. This is polar of P with respect to S equal to 0, I can say. This is pole of polar. So this is the concept. Here also P is exterior, this is the polar. I can say this is case 1. Case 1. P is exterior. Okay. Now we will take case 2. P is interior. Now. P is on the parabola. P is on the parabola. Okay, students, observe here. Yeah. This is parabola. Somewhere here P. Yeah. Through P you can draw infinitely many chords. This is one chord, this is another chord. So this is A, this is B. Yeah, through extremities of this chord we need to draw tangents. Automatically this is one of the tangent. Okay, Nana? So through A you can draw another tangent. Through B you can draw another tangent. Important thing is where they are meeting, at what point they are meeting. They are meeting at here, here, here. That's why this straight line, red one, becomes polar with respect to S equal 0. Important thing is in this case pole is on polar. Okay, here tangent at P is the polar of P. Also pole is on polar. Okay students, now I will take this is as case 2. Case 3 I will take P is interior of parabola. Okay, here also I want use a rough sketch now. So here P now. No condition for P. For circle, P should not be center of the circle. Here no condition for P. Okay, this is one chord. This is another chord. Like that, you can try infinitely many chords. Okay, Nana. Through extremities of these chords, we need to draw tangents. Yeah, for this chord, this is one tangent. My diagram is not good, Nana. Okay, feel that is exact diagram. Okay. Okay. Tangents is drawn. Their point of tangents is this will form a straight line. That straight line is called polar. Okay. Next, theorem number 2, Nana. How to find the equation of polar for given parabola. The equation of polar of P x1 y1 with respect to y square equal to 4x is s equal 0. Don't confuse. I will explain. So this is parabola. This is P x1 y1. What is P? Nana? Here only, no? P x1 y1. This become the s1 equal to 0. Not only for parabola, any conic same s1 equal 0 is for tangent equation, s1 equal 0 for chord of contact, s1 equal 0 for polar. Okay, don't confuse. The position of P will vary, no? So this is parabola. P is now here. P is here now. x1 y1. Now this chord of contact is s1 equal to 0. Understood? Now what happened here? Okay. Now P is exterior or interior or on. Okay. What happened? The polar becomes s1 equal to 0. Equations are same, no? The position of P is varying. You should take care. Okay. Now equation of polar of P x1 y1 with respect to y square equal to 4x is s1 equal to 0. Don't confuse. I will write let A equal to same alpha comma beta, B equal to gamma comma delta. Students, how I proved s1 equal 0 is the equation of chord of contact for the parabola, yeah, y square equal to 4x. Similar way, you can prove that s1 equal 0 is the equation of polar for the parabola y square equal to 4x. So A equal alpha comma beta, B equal to gamma comma delta. Now you want to prove that the line passing through these 2 points should be is of the form s1 equal to 0. Okay. Given parabola is y square equal to 4x. Observe students, important thing is so give some name for this. Say this is K and this is L. Say this is M and this is N. Yeah, for the point A, say alpha comma beta, PKL is chord of contact. Observe. This is, students, observe here, Nana. This is parabola. This is point A. Through A, 2 tangents are drawn. Okay. This is joined and extended. This is what you call this. This is called chord of contact of this point only, no? That's why I can say that PKL. I will write PKL. PKL is the chord of contact contact of A alpha comma beta with respect to y square equal 4x. Nana, this is very important step. This is very important step. Just I explain clearly here. Clearly explain here. Okay. Now I want to find equation of pKl, equation of chord of contact, equation of pKl, equation of pKl. I can say that's actually there is chord of contact. Just I am writing like that. Equation of pKl is, what is the equation of chord of contact? S1 equal 0 only. What is S1 equal 0? y1 minus 2a times of x plus x1 equal 0 only. With respect to alpha comma beta only, no? Instead of y1 you want to write beta, instead of x1 you want to write alpha, that is y beta minus 2a times of x plus alpha equal to 0. But this line is passing through x1 y1 only, no? This chord pKl passing through x1 y1 only. I will write, but this line passing through px1 y1. What the meaning of that? Instead of x you need to write x1, instead of y you write y1. y1 beta minus 2a times of x1 plus alpha equal to 0. Now I can call this equation number. Students, listen now. So what is PMN here? What is PMN? PMN is the chord of contact for the point B only. So that I will write here. So chord of contact of B with respect to y square equal to 4ax is PMN. So equation of PMN. Equation of PMN. What is that? y1 minus 2a times of x plus x1 equal to 0. With respect to the point gamma comma delta only, no? B means. Okay, what is the meaning of that? Y delta minus 2a times of 0. Again, this line also passing through P only, no? PMN only. I will write this line passing through px1 y1. So instead of x I can write x1, instead of y I can write y1 now. That's why y1 delta minus 2a times of x. Equation number 2. So here we will get important and final conclusion from 1 and 2. We can say y1 minus 2a times of x plus x1 equal to 0 is the line passing through alpha comma beta, A alpha comma beta comma B gamma comma delta. Observe here, Nana. Put alpha comma beta in this equation. From first you can say that 0 equal 0 means alpha comma beta will satisfied by this equation. Put gamma comma delta in this equation, Nana. By second equation you can say that 0 equal 0 only. Means you can say that gamma comma delta will be a point on this straight line. Through two distinct points you can draw only one straight line. That's why y1 minus 2 times of x plus x1 equal 0 will passes through these 2 points, means that is the equation of the polar. Final conclusion. Therefore, equation of polar of px1 y1 with respect to s equal 0 is s1 equal to 0. S1 means this one only, Nana. Don't confuse. One example problem. find the polar of 2, 1 with respect to y square equal to 3x. Direct approach, not big problem. Directly we want to find s1 equal to 0. S is given as y square minus 3x equal to 0. I want s1, that is what nana, y1 minus 3 times of x plus x1 by 2. So directly I want to write equation of polar of 2, 1 with respect to y square equal to 3x is, what is y minus 3 times of x plus 2 by 2 equal to 0, or you can say 2y minus 3x minus 6 equal to 0, or another words I can say that 3x minus 2y plus 6 equal to 0 is the equation of the polar. Important note. If pole is focus of conic, then polar becomes its directrix. Students, this is very important. If pole is focus of any conic, then polar becomes its directrix. So actual topic is parabola. By using parabola, I will prove this. Okay, this is axis, nana. This is tangent. This is directrix. So actually, I want to use standard parabola, that is y square equal to 4x. Automatically, s becomes a, 0. Now I want to find the equation of the polar with respect to the point s a, 0. I will write equation of polar of s, that is a, 0 with respect to y square minus 4ax equal to 0. So directly you can say that what is s1, directly I can say y1 minus 2a times of x plus x1 equal to 0. So what point a, 0. Instead of x you want to write a, instead of y you want to write 0. 0 y1 minus 2a times of x plus a equal to 0. This is nothing but x plus a equal to 0, which is same as its directrix. Okay, so this is important note. Again need to note this. Observe students, P is outside the parabola, then the chord of contact and the polar of P with respect to s equal 0 are coincide. This is important note. I clearly explained. This is a parabola, this is outside, this only chord of contact and this only the polar. That's why important. That is important thing. If P lie on the parabola, then the tangent of P and polar of P with respect to s equal 0 are coincide. Okay. If P lies inside the parabola, then the polar of P with respect to s equal 0 does not meet the parabola. So P is taken as inside. This is become the polar equation. This polar line never made the parabola. Next, polar line can never be horizontal line. Important now. This is also important note. Polar line never become horizontal line. Yeah, okay students, next important theorem. I can keep star marks. Yeah, pole given, how to find polar I explain. Okay, now polar given, how to find pole. Interesting thing, observe here. Yeah, this is the conic, this is the polar, Lx plus My plus n equal to 0. So now you want to find coordinates of P. Let coordinates of P is taken as alpha comma beta. Now I want to find alpha comma beta. I will write, let pole B P alpha comma beta. One thing. Okay. Yeah, given polar is Lx plus My plus n equal to 0. Say this is equation number 1. Next, given parabola is y square equal to 4ax. Okay, first of all, without using this line, I will find the polar of P alpha comma beta with respect to this line. Then I will compare with Lx plus My plus n equal to 0. From there, we will get the values of alpha and beta. Okay, directly I went right. Observe here. Yeah, right. Equation of polar of alpha comma beta with respect to y square minus 4ax equal to 0. That is S1, no? S1 only. S1 should write here. What is that? y1. Yeah, minus 2a times of x plus x1 equal to 0. So now what should do, Nana? Instead of y1 you need to write beta, instead of x1 you need to write alpha. So beta y minus 2a times of x plus alpha, or 2ax minus beta y plus 2a alpha equal to 0. This is the equation of the polar. I think 1 and 2 are identical, no? Because both are polar of the same conic only. I will write 1 and 2 are identical. 1 and 2 are identical. So a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0 are identical lines. Then a1 by a2 equal to b1 by b2 equal to c1 by c2 only. That's why 2a by L. 2a by L. Wait. 2a by L equal to 2a by L equal to minus beta by m. Minus beta by m. Equal to 2a alpha by n, 2a alpha by n, 2a alpha by n. By using and comparing this, we want to find alpha and beta. Just I want to compare these two first, Nana. So 2 alpha 12 get cancelled, alpha equal to n by L, alpha equal to n by L. Okay, now I want to compare first to last completed. No, I want to compare these two to get beta. So beta is equal to minus 2am by L. Therefore pole of polar Lx plus My plus n equal to 0 is, with respect to y square equal to 4, that is important thing. What is that? N by L comma minus 2am by L. Should remember. Okay, n by L, n by L minus 2am by L. So I will take one example for that. Okay students, one example. Yeah, find the pole for polar 3x plus 3y plus 4 equal to 0 with respect to y square equal to 8x. Okay, Nana. So for solution for this problem, L stand for 3, M stand for 3, yeah, N stand for 4, A stand for 4A. You know, this is y square equal to 4ax means 2. Just substitutions only. N 4 by 3, comma, minus 2 into M means 3 by L means 3 get cancelled. So what happened Nana here? Minus 4 by 3 minus 4. Okay students, important note. So if you don't know the formula, do one thing, try to find S1 for this equation with respect to alpha comma beta. So you get a polar equation, compare with the 3x plus 3y plus 4 equal 0. From there you will get alpha and beta. Okay, yeah, pole of 2x minus y minus 4 equal 0 with respect to x square minus 4y minus 8y plus 12 equal 0. Students, two ways you can solve this problem, Nana. First method is after converting x square minus 4x minus 8y plus 12 equal to 0 into standard form, and by using formula you can find the pole, or by the second method is without using any formula you can find. Just I want to find polar of this conic with respect to a pole alpha comma beta. After that I will compare with the 2x minus y minus 4 equal 0. From there I will get alpha and beta. Okay, let P alpha comma beta be the pole of x square minus 4x minus 8y plus 12 equal to 0. Now you want to find polar equation. Okay, so according to the definition of polar equation is what, Nana? Polar is nothing but S1 equal to 0. S1 means instead of x square x1 should write, minus 4 instead of x plus x1 by should write, okay, minus 8 into y plus y1 by 2 should write, yeah, plus 12 equal to 0, or x1 minus 2 times of x plus x1 minus 4 times of y plus y1 plus 12 equal to 0. This is the equation of polar with respect to the point x1 y1, but with respect to alpha comma beta you want, no? That's why I can say this is alpha x minus 2 times of x plus alpha minus 4 times of y plus beta plus 12 equal to 0, or simplified form alpha x minus 2x minus 2 alpha minus 4y minus 4 beta plus 12 equal to 0. Now I want to write in standard form alpha minus 2 into x. Okay, only one y is there. Okay, minus 4y plus 12 minus 2 alpha minus 4 beta equal to 0. I can say this is second one, so this is a first one. So 1 and 2 are identical lines. 1 and 2 are identical. So what is the meaning of that, Nana? Alpha minus 2 by 2. Alpha minus 2 by 2 equal to alpha minus 2 by 2 equal to, yeah, minus 4 by minus 1. Minus 4 by minus 1 equal to what is this? 12 minus 2 alpha minus 4 beta by minus 4. 12 minus 2 alpha minus 4 beta. 12 minus 2 alpha minus 4 beta by minus 2. Now I want cross check with that. Yeah, minus 4. Oh. Yeah, this is minus 4. Okay. Yeah, while comparing these two, directly we get alpha nana, minus minus get cancelled, 8, 10, alpha equal to 10 directly. Now I want compare these two to, no, sorry. Now I will compare these two, find the value of, beta. So minus minus get cancelled, minus 16 equal to 12 minus, just now you got alpha as 10, 20 minus 4 beta. Okay, so what happened? Minus 16 equal to, this is minus 8 minus 4 beta, or 4 beta is equal to minus 8 plus 16. So beta, 4 beta equal to 8, beta equal to 2, therefore pole, directly I can say that 10 comma 2.